Okay. Good afternoon, everybody. After lunch, most people are here. Looks like the room is pretty full. It's a pretty big room. So let's get into descriptors and metaclasses, the simple stuff. Yeah. So this is a tutorial I've been teaching, at least the third time now here at PyCon US, and we will see how far we can go here. So just a few words, the introduction that you know who I am. So I'm a Python user since 1999, so I can always say the last millennium, so it's quite a while. I started with Python version 1.52, and I did my first Python training in 2004. And I do a lot of Python training actually, because I'm also working at Python Academy, and besides teaching a lot of Python, I'm also involved in a community. So I've been chairing Python conferences, quite a few. So EuroSciPy, the first EuroSciPys, I organized pretty much most of it and chaired, and 2 PyCon DEs, which is the German version of PyCon, and also EuroPython, which was a pretty big conference in 2014, and also chair of the German organization for Python, so the kind of German PSF equivalent. So I'm doing quite a bit with Python ever since I discovered it. Okay. Click in here. This doesn't work. So I would like to know a little bit about you, so I get a bit about your background. So I just asked you a few questions. So who has used Python less than 1 year? Please raise your hand. Less than 1 year. Very few people. Between 1 and 2? More people. Okay, 2 and 5? Okay, that seems like the majority. More than 5? Oh, quite a few. So thank you very much. So who is mainly using Python 2? It's about half. And just who's mainly using Python 3? Should be the rest, I guess. Yeah, it's not really half yet. So I will do the thing with Python 3, but the material is designed to work with Python 2 and 3 alike. If there are differences, I will point them out. So it should be equally useful for Python 2 and Python 3. Sometimes there are some differences. Some things work with Python 2 and some work with Python 3. So I will use the IPython notebook as a teaching material. You don't have to. Who of you is familiar with the IPython notebook or Jupyter notebook? About a third, yeah. So if you have it, you can use it. It's a very nice thing because it's very good for experimentation. That's what we do at the time we do something. If not, you can use an editor or whatever interactive environment you prefer. That's fine. It's not essential. It's just if you want to see exactly the same as I do, then the IPython notebook is there. I'll send you some instructions how to install it if you want to. Otherwise, there's not much else to install. We just need plain Python. There's no libraries we need to install, and that's just I gave you a few example scripts, and that's all we need. Okay, just an overview what you're going to expect. So we will do pretty much a hands-on session. So I try to be not too fast. So you should have most of the time the opportunity to follow along, typing a little bit, so that you not only sit and consume it, do something. That's important. So you move your fingers a little bit, type, and try things out. So either I do some interactive examples, or I give you some scripts, and you can at least run them and look at them and maybe change them a little bit. So I use IPython notebook, as I said, which is recommended. Any other Python tool will be fine. You have if you have the download, everybody has a download, yeah. Then you have a PDF. This is about this one here. It's about 30-something pages or so. Let's see, 40 pages, 43 pages. This is pretty comprehensive. This should be okay. So I had a tutorial in the morning. The 75 pages was a bit too much, maybe. Yeah, there's a link to the download. So I just give you the link. Just a minute, I have to open a new tab. So it's a Python Academy. Python Academy. Why does it? Oh yeah, it doesn't come up. Academy. Python with 1T. So download, then download. I should have copied it somewhere. Download Python PyCon 2016. Yeah, 2016. So it's not that early. Hey, what is it doing? Why is this? Just a minute. I copy it just from just a second. I copy it out of my thing, so just have to go over here to go to my files, and it's right there. In the email I sent. Yeah, so that should be it. Assistant, yes. Okay. Yeah, that's the old one that doesn't work. Just I have a new one. Just a minute, I'm coming up with a new one.
So download / PyCon 2016, and then is what's different. Deco _ meta, DCO _ meta, and /DCO _
I have it now. So just because the screen is switching back and forth, it's kind of a little bit strange. So I have it here. This is a link, and it's supposed to work. So this is actually, this should be the thing. So if I copy this into the browser, which is this one here, then it should work. If I have internet connection, but obviously right now I don't have internet connection. So this is a link. Go there and download this. I sent the email to everybody through the interface. There's an interface over the conference interface, and sent the email. The link wasn't there. Unfortunately, the first link was wrong, but the second email corrected the link. Okay, so if you have this, you will get some sample scripts, and you have run some sample scripts, and also a few other things. Okay, I just move everything. It's on the same page. So you have this handout, the download also. So we do some exercises. Actually, I'm really planning doing some exercises. You do something yourself. And after this one, I will also send you the solutions, but not before. And we have a 20-minute break, 3 o'clock, there will be a break. And there's also a feedback, so I put a link in there. The link is also in the download. If there's a small file survey link. So you can give your opinion after the tutorial. The organizer asked me to do this. That's pretty much it. I have a few more organizational things. So lunch is over. We don't say anything about lunch. But also the power, there's only a few power supply things here. So that's what people can please share. But if you have a longer cable, it should work. Looks like there's quite a few here. Good. This is about, that's all about introduction stuff, and I just make this bigger so you can see better. Okay, so the first thing is about descriptors. And so I'm the descriptors. Seems like I killed the descriptor. Oh, this is here. Descriptors. We chose to have two different topics. Descriptors, metaclasses. Pretty much before the break, I want to cover descriptors, and after the break, pretty much metaclasses, more or less. And these are kind of more complicated or complex topics here in Python. And they're also not maybe you might not need them for quite a while, but it's interesting to know what the descriptors and metaclasses are. So they are not needed for many tasks. So to some degree, this is a little bit academic, just for the curiosity that you know how things work. But maybe when you know how things work, then some other things might fall in place easier. So they can be useful from time to time. It can be useful at least to know how they work, because you might encounter some packages that make use of them. And then it allows you to better understand how those packages work. Whatever you install, then it might be useful to do. But rather, sometimes they can prevent writing boilerplate, so that you can make code shorter when you use them correctly. And sometimes you can get a more elegant solution than just writing it without them. There's always a solution probably without them, but not nearly as elegant, or maybe much more work, depends. And sometimes they can be useful, especially metaclasses can be useful if you want to explore code bases. So I have some examples where you want to dig in the code base, you don't know too much about it, then it can be useful to use maybe metaclasses to get something out you wouldn't get with other tools that easily. So there are some different, I hope I can show you a few applications that are useful, though they can make use of them. So they're not really very simple solutions, so if you use them, you might make things a bit opaque, so a little bit, for other programmers, not obvious. They might not really see immediately what happens. Something happens, some magic in the background, and they don't see it. So this can be not a problem, it can be a problem, depends what it actually means. So if you overuse them, if you use too many metaclasses, too many descriptors all over the place, you might make things too complex and too difficult to understand. So this is a fine balance, but still they can be interesting how they work. So that's why I wanted to teach you but a little bit theory behind how they work, and then show some practical applications. So it's just for some academic things, so you just know how they work. Or maybe you don't do anything with it, it's fine. But also, as I said, some libraries might use them, so it is good to know. And you should use them wisely. So I also will advise when not to use them, actually. Hold on. Give my opinion. Descriptors. So descriptors is a feature that allows you fine-grained control of attribute access. It's all about attribute access. If you have an instance of class or something, you access an attribute, then you can decide what happens. You can decide what happens. And this is something that can be pretty powerful because you do attribute access quite a bit in Python. And you can control, and very often what you do some control, you narrow the choices of the user of this instance because you don't allow a few things not to happen or something like this. And this can be useful at times. So this is a little bit what you can do. Okay, so as I said, I have the handout, and I will pretty much go through the handout. So if you lose me somewhere, you should be able to just go to the PDF, to the handout, and you should follow up, because I'm pretty much going with what's in the handout. So then you have a chance to work through. So metaclasses will be the next topic, so I just go out of here. And I'm going to open an IPython notebook, and then we work with IPython. Okay, to do this, I just go, I just created a new directory here, and I activated Python 3.5. So I'm going to do the main thing with 3.5 from time to time, or if questions, I also go to 2.7. I hope nobody has older versions than 2.7. There might be a few differences, 2.7, 2.6, but not too much. So I'd start a new Jupyter notebook. So the IPython notebook lately got renamed to Jupyter, the whole project, IPython. That's why I started Jupyter notebook. And you just, if you have it installed, it starts. If you don't have it installed, don't bother right now to install it. And then it will open here. So it will open here, and I can just also move to a different browser. Typically, I can use this one. It's a bit nicer. So I have the dashboard, so people don't know how to use it, know what a dashboard is. And I just make a new Python 3 notebook, and I make it a bit bigger so you can see something. And I call it descriptors. This will be our thing when I just turn off a few things so it gets more space. So the first thing we want to look at actually is properties. So properties is one application of descriptors, and it's a bit simpler. And for many cases, properties might be enough. So I will dive down a little bit into properties to warm up. It's also easier to understand. And then once we have properties, we look at the descriptor, which is more, you can think of a generalization of properties. So that makes a bit more sense. So first thing, properties. Properties here. So now I have an example, and I just define an example. So you're welcome to work along if you like. So I actually do this here. I have a square, so a normal square, and you need inherit from object. When you're in Python 2 and Python 3, it's not necessary, but it doesn't hurt, so just do it. And then we have our init, and inside the init, I do a few things. We have self, and we have a side. When I set self side equals side. So that's just my init. And now I add 3 strange functions here, or actually methods. And they are important for properties. There are different ways defining properties, and this is the first one I show you, which can be useful. And I have one that's called aget self, and I just return here, return self side times side, or squared if you want. This is the same thing. So, and there's another one which is called a set, and then I have a set self value, and in this case I just want to turn it off. You can actually do a variation if you wanted to, and we can do this later and modify this one. That set is actually doing something. But for now, I just say print no. Yeah, something like this. And the same thing we do for a del, for like delete, and then we just also say. Okay, this is nothing special so far. Now the special comes when I use the property. Property is a built-in function. You will see in the next stack we use it as a decorator. Here I use it just as a function. And I say area is a property. That's one way of doing it. And sometimes it's the right way. Property. And I just throw in my 3 functions in this order in a doc string. So my aget, my a set, and my a delete. And I specify a doc string. So you should have a doc string here. And you tell what is the square, the area of the square. So I'm too lazy to type this area here, so say right area. Okay, and this is this built-in function property, and this has some effect in it when I make an instance. And you see how this works. So I have an instance S of my square, and I say, okay, it has a side of 5, and now if I access area, I get a side of 25. So that's what happens. So I do, you see, I access an attribute, in this case area, and it's doing something special. It produces a 25, so obviously 5 times 5. So if I access it, it actually calls the aget. So if I do a get. If I want to set it, if I try to set it to something, so I say that's not enough, I want to have it. So I just get a no, nothing happens. And if you look at it, the area is still the same, hasn't been changed. Because I implemented this a set, and I just print out no. So this is the way you can write a property here. The thing is, it is pretty important that it's a property, and you hide this a little bit, the property, and you have these 3 methods here. We have 3 methods that you don't really see what they're doing right away, only makes sense when you put them in here. So therefore, there are different ways of writing properties. So if you go to this download, there's a directory properties. Properties, and inside the properties you have a bunch of, actually 2, and you can just open it in your editor. I load it in here, which is equivalent. And now I have a different way of actually defining it. So I always use from future import print function, though the whole thing works with Python 2 and Python 3 alike. There shouldn't be a difference here, it should be the same thing. So now I have my square again. And now I use it differently. I use this property as a decorator. So the decorator is nothing else than a function that typically takes a function and returns a new function. And that's what we did here. So you see this property is a function that takes a bunch of functions, in this case, and returns a new function area. Yeah, a method is nothing different than a function. Actually, in Python 3, it's called function. It's not unbound method anymore. It's a function. And that's what happens here. I use a decorator, and now you see I have to call this area. So I don't have this double naming. I don't have to say area equals property as I decorate this with area. And this would be the get. And it would be enough if you just want the get. But just to show you what you can do, you can also have setters, then setter and deleter. And for this one, strangely enough, you use just the name of this method area, and this one has a property now setter, which gives you a different decorator for this one. That's how it works. This is totally equivalent to the first one. This one is totally equivalent to this first thing I wrote. This is totally equivalent. And now you see what I'm doing. I'm just making an instance here and run it. And if I run through, then you see that you get the same result. Okay, that's what you can do. But I think there's even maybe an interesting other approach if you write them a lot. I have another approach I would like to show you, and this is this nested one. So if I load this nested one, nested, and now I take advantage of a few features of Python, and I do the following. Now the usage is easy. So just look at the usage first and then look at the implementation. So we have our class square again, the init is the same. And now we use this decorator nested property, which I define up there, and you look in a minute. And now I have three functions, fget, fset, and fdel, which do exactly the same we had before, but these functions are nested. Now you see, okay, they belong to this property. Yeah? And then I just return locals. Locals is a function call, it returns a dictionary with the local names. In our case, it's just three of them, fget, fset, and fdel. And then I do what? I just have this nested property, which is a decorator, takes a function. Here gets the names by calling the function. And then it just also adds to these names, which is a dictionary, adds the doc string, and using the doc string from the function. And then I call property using this syntax with a double stop. So let's look at this in steps. So first of all, property. If you look at property with a question mark, or you just say help, then you get the help, and you see property takes keyword arguments, fget, fset, fdel. So for this way, I have to call them exactly like this, because I just supply them with a name, and I use a dictionary to take them apart. I use a dictionary. So locals gives me a dictionary. A locals call gives me a dictionary with these things in there, with a name and the value. And then I have this dictionary, and then I can use it. And that's why I need this doc. Okay, so let's look at this. I'll get rid of this. That's what we're doing here. So this one takes a dictionary. So what I'm doing, I take these names here and to apply this as a dictionary to properties. And take it apart. They take a dictionary apart as keyword arguments, and this here names is a function I call, and you see I return locals here, and this area is a function that returns locals. So I call this function, the names is locals, and then I can add my doc string. So if you want to explore this a little bit. So it works exactly as before, but if it's too difficult to understand, of course, you can always put maybe a print in there, and you can check. So let's look at locals first. Yeah, print locals. Then you see what locals gives you. Print locals. And then you see the print of locals. See, locals is a dictionary, which has these names, fset, fget, and fdel in there, and then has this function. This is just a representation of the function, which is in there. That's the first thing. So this locals is what this function returns. And this decorator is applied to area. And area is func. Here is my function. When I call this function, this gives me, now if I print names here, yeah, if I print names here, yeah, the E, this one, it's the same. Now this is just locals. the names is just locals. And what I'm doing, I'm adding to locals, so adding doc. Yeah, and I'm using the docstring of the function itself, which is this docstring, and add it here to this dictionary. And then I use a double star syntax that unpacks the dictionary and the keyword arguments and calls my property. So this is quite a handful. Yeah, it's quite a few things that happen here. But once you implement it, you don't have to think about it too much anymore. You just need to apply it. It's a little bit nicer because now these three functions, get, set, and delete, are inside this area. So this is just an alternative. Just interesting that you can do this. You don't have to, but it's interesting. Okay, this is properties. And properties can be useful on their own. The thing is, you need to set properties in each class, and the generalization actually of properties is descriptors. So, and when you talk about descriptors, we can distinguish between so-called data descriptor and non-data descriptor. We come to the difference in a minute. And just, I do this. Look at the data descriptor. So I developed this notebook here, and I also make this notebook available just in case I do something different than you do. Then you can still have this notebook. And I just go up in the descriptor directory, and then you see the descriptors here. When I have a bunch of descriptors, bunch of files with descriptors, and the first one is what's called a data descriptor. Load data descriptor. Okay, this is a data descriptor. And this descriptor, it's a kind of different than a property because it's more general. So again, we have our future import, and we define a class, but we'll see we don't use this class in a normal way. We don't make an instance of the class in a normal way. So this class has, in this case, an init, which is not totally necessary, but for our case, we have it. And then we have these three methods, get, set, and delete, all with this double underscores in the beginning and so-called banter methods. And these make up a descriptor. So if you have a get and a set, you have a data descriptor. If you don't have a set, then you don't have you have a non-data descriptor. So if you have all of them, you have a data descriptor. And they don't do much. You see, they have this, the get has to have this instance and class here. Obviously, you get the instance the class. We'll see in a minute what it means. And the only thing, I just print something here, and I return my value. And the same thing if you say set, there's an instance and a value, and I print something, and then I try to do something. I first try to uppercase my value, which obviously only works with this value has a method uppercase, so it's a string typically. String has an upper method. If not, I just use the value itself. And delete is not implemented. That's something you can do. Okay, this is how descriptor is defined. It doesn't help too much so far, but this is the protocol. You have this get and this set with the underscores for this descriptor here. This delete doesn't necessarily have to be there. And now, what you can do with the descriptor, so you don't make a normal instance. The descriptor is solely used. So I make a strange class because it behaves a little bit differently here. And I inherit from object. And I do the following. I define an attribute. And this attribute is actually my data descriptor. So, and that's typically how you use a data descriptor. So you create class attributes. This is the class attribute. You have to do it in the class. If you do it outside the class, it doesn't work. It doesn't do what you want. And now you can go ahead and you can make instances of the class, and then you see what's going on. Strange. Here, and it doesn't take any init. So I have this one. But now if I access it, see, if I do this, this is tab completion. Just press tab. It gives me this attribute. It's there. So obviously this iPass notebook tab completion knows about it. And when I execute a cell, I get my text. You see, data descriptor get. That's what I print here. And returns the value, which is 0. In this case. So I intercept this attribute access in a different way than the property, so it's more general. And when I access this attribute attr, in my case, something happens, and it happens to what I programmed there, what I programmed in the get method. So let's have a look what happens. Actually, when you do this .attr, a lot of things happen. When I write it out, typically you don't need to remember what I'm writing out right now. It's just to see what happens behind the scenes. So the first thing you get, if I say type as, I get the class. So because this attribute is always in the class. First is type as, and then actually you go inside the dictionary. The dictionary is the namespace where all the attributes are located. And in this dictionary, which I access like this, I get attribute. So I get this attribute here. And now you get this data descriptor. You see, I have a data descriptor. And then this one actually calls the get method. And now it has to put in the instance and the class. And again, to get the class, I use type as. Something like this. So these two lines are totally equivalent. So if you say .attribute, this happens in the background. Quite a bit of lookups. That happens there, and then therefore you can now determine what you want to happen when somebody is doing this attribute access. Yeah, good. So maybe this dict, yeah. If you look at this class, this dictionary inside the dictionary, typically this is a mapping proxy, so it's read-only. And most of the time you don't bother to do anything with it. It's just for information to see what's inside, and this is a namespace. So if you say dot, something typically that looks inside the dict, and you see there's a data descriptor in there. There's no attr. The name attr is a data descriptor. It says there's no 0, but still when you say attr, you get back a 0. So that's how it works. So. And now, that's how I implemented it. I can also set it. I can say now my s.attribute equals something else. And now if I get my attribute back, I get this back. But I can also say s.attribute equals abc. And now if I try to get my attribute back, it's uppercased. You see, if it's 10, nothing happens, and if the string's okay. It does make a lot of sense, of course, in terms of what it's doing, but you see it's doing something. So you have the power to determine what happens if somebody accesses an attribute and if somebody sets an attribute. So in this case, I try to uppercase it. If it works with a string, it's fine. If not, I just take the value as it is. And that's what the descriptors are all about. So now you have this power to do something with attribute access. So the thing is, those attributes are always, these descriptors are always stored in the class, though they are not actually in the instance, they're in the class. But of course, if you try to access an attribute instance, it's not in the instance dictionary. So my instance dictionary is empty. So an instance also has a dictionary that stores this, but everything you say self dot is typically stored in this dictionary, but my s doesn't have any self. If you look at my s, my class here, my instance s, there's nothing, there's no method, there's no self. If you would have an init with a self, it would be stored in there, in the dictionary, but there's no init, there's nothing. It's just this shortest class I could write. That's why the dictionary is empty. And that's how the lookup works. Typically, it looks in the dictionary of the instance first. If it doesn't find it, it goes to the class. That's how the normal lookup works here. So, and of course, if I try to delete it, if I say now delete attribute, then it doesn't like it, because it will go through. It doesn't try to delete the attribute from the instance. Actually, it goes to this descriptor and gives you this message. Good. This would be a data descriptor, which also has a set. You can also have a non-data descriptor, and I have given you an example, which is a bit different, because then the setting is different. So let's give you an example. And we will see this is non-data descriptors actually used quite a bit. in Python of an object, and I just set the values. I do similar things here as before. So I have my init, and I set my value. No, not here, just init. And I set the value here, so I don't supply it as argument, but it doesn't really matter now. And then I have only my get, but there's no set. Only the get, which here had this instance in class. So we have the same interface, instance and CLS for class, and then I just return something. You can print whatever you like, so just you have to see, and then I return self-value. But there's no set, and now it's a bit different. So I make a class at 10. Yeah, so the usage, again, you cannot use it alone as a standalone. You have to use it here. I make my non-data descriptor instance here, and then I have 10. I call it at 10. I make an instance of it. Ah, yeah. So I called it at 10 because I say value plus 10. So it doesn't matter. The thing is, now the access. I have this instance, and I can now access it, and this access exactly the same. When I access it, the get will be called, but there's no set. So the 10 dictionary is empty. But now if I set attribute, to something, then, and if I call it again, it's 20, because now if you look in the dictionary, I didn't intercept the setting, and the dictionary is now filled with so. It finds it there first. So that's always a lookup. First, when I say 10 dot attribute, it looks in this dictionary. Now the dictionary contains attribute, it will take it from here. If not, it goes to the class of the descriptor. If there's a set, a descriptor, I won't get there because the descriptor will intercept it. Because there's no set, there's also a non-data descriptor. So that's a difference. It's just a theoretical difference, but we'll see in a minute what non-data descriptors are good for. Good. So when if you want to use descriptors, you always have to write new style classes. So if you work with Python 2, there's this thing called old style classes, which are really old. So I think in 2.2 we have new style classes. So if you don't put object here in Python 2, it won't work. So if you don't put object, you will get strange errors because it doesn't work at all. You can still define it, but you cannot use it the same way. So you always need to put object. In Python 3, there's no old style classes anymore. It will always work. So old style classes have been deprecated for quite a while, so don't never use them because then descriptors won't work. Okay, this is the main thing how it works. It's just a little bit theory. Yep. We have a look at a few examples what we can do with it. A few more things about two more attributes. Are you familiar with this method get attr and get attribute? Who knows what the difference is between both of them? Yeah.
One checks the attributes if they don't exist.
Yeah. Yeah. So the get this first, the short one, get attr will be called if you try to access an attribute that doesn't exist. If it exists, it's fine, we'll take it. If not, it goes to get attr and we'll do kind of, it's very often used for delegating. You want to delegate an attribute access to somewhere else. That's a typical use of get attr. So if an attribute doesn't exist, the first one is called. Get attribute is much stronger. Get attribute is the first one that always will be called. So if you implement get attribute, then inside get attribute you should never say self dot, because when you say self dot, get attribute will be called, and then it goes in there and says self dot, and get attribute will be called, and this is a recursive thing. They're never going to finish. So after 1,000 times, you get a recursion limit error. So get attribute it's not that often used, but it's pretty strong. Therefore, you actually, when you do this, when you implement get attribute, you override the data descriptor. So this has precedence. So let's have a look. I have this here. I have this class, which I call, that's just an example, but I just said it, you can see it and it makes sense. So I have this class overridden, I call it, and then I have my attribute, which is my data descriptor. But then I implement get attribute. Get attribute here. And when I do this, it has to be name, because I want some attribute. And when I do this, now I can make an instance. I can just delete this one here, that's in the way. I make an instance of my class, and then I work with my class. So, and now if I try to access my attribute, then no way. So this get attribute is stronger than the descriptor. That's important to know. So if you have a get attribute, then you won't be able to access this descriptor. The class I'm referring to, it does make a lot of sense. So this attribute will not be reachable from there, so that we wouldn't write something like this. But it's important to know which one comes first. And this get attribute is very strong, and you have to be careful. Typically, you cannot use self. You have to go through the class to find methods or something else. Otherwise, you get a recursion. Okay, this is the theory. Now, the first application, which is more an interesting thing, is functions are non-data descriptors. Okay, what does it mean? Let's have a look. So functions as non-data descriptors. So I define a function. It doesn't do anything. So I just have a function. And now, when you can say function, func, get. So if you look at this, they have func. Functions have this get method. You see? That looks familiar here. You have this get. And now you can define a class A, which inherits from object. And now you can define a method. And this method just has a self and doesn't do anything, just to be there. So it's always nice to have a pass explicitly there. So now I make an instance of my class. And I have a method. And if you look at this, it's a bound method. But if you go to the class itself, you have an unbound method or a function. If you look here, you have just a function. In Python 2, it's called unbound method. Here's a function. And now, how do you get from this function to this bound method? And to do this, you use this non-data descriptor. Actually, that's a way to get there. And how to find it. So remember this line up here, this long thing where I showed you how to get there. Where is it? This one, this long line. You say dict, attribute, get, and so on. And actually, you can use the same thing to get from this function to this bound method, and then this is the application. So you say type of my instance A gives me the class A. There I go into the dictionary, exactly the same as we did before. I go to the dictionary, and I go, this is a dictionary, and I retrieve my method, and then inside the method I say the get, I use a get, and the get I have to again give it the instance and the class, and the instance is my lowercase a, and the class would be uppercase a. So this is the same thing, and now I get a bound method. That's what happens. So actually, as soon as you write classes and use methods, yeah, and you use method instance, you use non-data descriptors. This is just interesting details. It's not too useful, but it's interesting to know how things work. Ah, yeah. Thank you. But it still works. Should be lowercase a. Because you have to put in a class. Yes, but if I say type of a, you get type. Oh, why does it work? Seems like. But it should be lowercase a, that's right. So because you want to have the class itself, but still gives it a bound method. Good. So now we get a bit more practical. First, we have to know how these descriptors work, and then I have a few examples. And then you have to do some exercises on them. So descriptors work in the class, and this is the thing you have to know, because if you don't know the it, you might get some strange effect. So we have this class storage. So I load class storage, and I'll show you how these things work. So if you use descriptors, you have to be aware that you store attributes in the class. So we have the class storage. So I have a descriptor, and again I set a value which has a default of none here. I have a get and I have a set. They don't do anything special. Typically you would do something different, otherwise you won't need it actually. And then I apply it here, and I make a class and use my descriptor and set it to 10. And then I make two instances of my class, store1 and store2. And I access my attribute, which is fine. And then I change only the attribute of store1 and print them out again. And once I do this, you see store1, both are 10. And now I change only store1, but my store2 also changed. So if I print this out, I changed only, I didn't set store2, but it changed along, because the value is stored in this descriptor, and the descriptor is inside the class, and there's only one class. You have two instances, but only one class. So it stored this value inside the class, and when I access it, no matter what instance I use, it will have the same value. So if you want this, it's fine. So there might be applications where you want this. Like a normal class attribute, you want all the instances to see the same thing. And if one of them changes, everybody else will see the change. That's a normal case. If you use a descriptor like this, everything will be stored in a class. Yeah? So you can use it in a class. If you don't want this, I have two alternatives that get a bit more complex here. Two alternatives what you can do to store them. Both of them have a few things that maybe not so really nice, but let's have a look how you can do this, how you can store things in an instance actually, because everything is stored in a class. So I'm loading the weak key dict storage. Weak key dict storage. So I'm using this weakref module in Python. So this weakref module in Python, it's there because here I would have the problem if I store some references to some objects that would not be reachable anymore, or at least they would keep a reference to an object that I don't want anymore. That's why I use a weak key module, which gives you some functionality to actually create references to objects that are weak. So if somebody else deletes the object, this will go away also. It doesn't create an extra reference. In this case, I use a special dictionary which can use keys that are weak. So if the object goes away, the key value pair will be deleted from the dictionary. Okay, and that's what I'm doing here. So I have in my descriptor this hidden weak key dictionary. I make instances of weak key dictionaries. This behaves like a normal dictionary. So the interface is the same as a normal dictionary. And you see, I do this, and I have it here in the init, and when I say get, I go in this dictionary and use get. So it's just a normal dictionary, has a get method, and I go in with the instance. So this assumes, that's also one of the assumptions, that the instance is hashable, which is not always the case, which is a problem. So we have this instance here, and then if there's the instance is not in there, I will return the default value. It's a normal dictionary lookup. And setting is the same. I can just use hidden as a normal dictionary, and I just set it here, and it will set the value in the dictionary. So you can do this. Yeah. So I use this weak key dictionary. And now I do the same application as before. I create two descriptors with two different numbers. I make two instances and print them out, and then I start changing them around. I change the first one in the first class, the second one in the second class, and the first one in the second class here. Yeah, there's two classes and two attributes, so four different names here, store1, store2, attribute1, attribute2, both of them. And I print them out. And I also have a look inside this dict. I look inside this hidden dictionary here and check what's in there. And then if you do this, you see I'm setting them, and both of them are 10. And then I change them. You see store1 has 100, store1 attribute2 has a different value, and store2 has a different value. So all of them have a different value, which is important. You can do this, and you can look inside the hidden dictionary, and you see things inside the hidden dictionary. It's just this instance here with a value, and once I delete it, this dictionary will get shorter. So there's two entries, and when I delete it, it gets shorter because there's no reference, and when I delete the original object, this weak key dictionary just releases it. So that's something you could do if you wanted to store something in an instance storage. There's one method. The drawback is this method assumes that instances are hashable. In this case, the instance is hashable, but there can be cases where an instance is not hashable, and then the thing breaks.
Can you use two different dictionaries to store for two instances also? So here everything will get for both instances will get hidden.
Yeah, you can have different strategies. The problem is you have to distinguish, because the only thing you get here, you get the instance here. When you say the get, you get the instance. And somehow you have to have a different solution where I actually store something inside the instance. I'll show you the other solution. Because you only have the instance, and you have to somehow associate the value with the instance. In this case, I use a dictionary, which is the thing, and I use the instance itself. I tried the version with the ID, which is not that easy to implement. Because this has a small problem. An instance, if you write the class in a certain way, it might not be hashable, and then it breaks. And that's the next example, actually. I want to show you. So if you write it in a certain way, so I use this from up there, this weak key dictionary. And I make the same thing, but there's two ways where I can break it. When you implement your hash, and for instance, you raise not implemented in hash, then your class is not hashable, because per default, an instance returns ID from when you hash it. You need to hash it to put it in the dictionary. Or alternatively, you could also define an equal, and not if you don't have a hash function and you have an equal, then it's also not hashable. You would need to define your own hash function to return something like the ID. So if one of these is there, when you run it, then you will see, then you get you see I get my non-implemented error because it's calling the hash. That's not hashable anymore, and I cannot use the instance as a key in my dictionary. So this is a small drawback to this method. Yeah. And as an alternative, maybe you have a different idea what you can do here. And as an alternative, actually, I have this. Yeah, class storage, so instance storage. That's the alternative. And what I'm doing here, actually I store something in the instance itself. And to do this, I need to create some kind of a unique name. And you can just make up something that nobody's using. I make it very secure. I use a UUID. This is a module that comes with Python, and this creates a very long hexadecimal number in this case, which is unique, which won't be recreated anywhere. So it's not possible actually that anybody creates this name. And in addition, I use also 2 underscores, and put 2 underscores. So this is here. I create this hidden name. I use 2 underscores and create this UUID. UUID4 gives you this long hexadecimal string or number in a string. And I use your underscore, so it will be hidden. So it won't show up in any IDE. You still have access if you want to it, but you cannot see it by accident. You won't be able to do anything with it. And that's what I'm doing. And I use this hidden name. You see, I assume that self has this hidden name. Otherwise, I return to the default. And here, when I set it, I use this hidden name. Yeah? So now I store the instance. So every instance has its own value. This works nice. There's no problem. The only thing, you have this strong, long thing in the instance, which you might wonder where it comes from. But since it has 2 underscores, you wouldn't see it if you work interactively. Only if you look in the dict, you will see it. Now I do exactly the same as before, and then you can see now it works. And this also works. It doesn't have to do anything with hash or not hash or something. It works. The only thing, you have is a strange number in the dictionary. That's the only drawback you have. Yeah, but Python adds a lot of underscore things anyway. You never even bother to look at it, so you have another one in there. This would be an alternative, and this would store it in the instance. Actually, this was my first idea to do this, and then I tried the weak key because I read it in this, I think, effective Python book. It's given there, and I think it's this implementation with the weak key dictionary, but this has a drawback that it doesn't work when the class is not hashable. The instance is not hashable. Okay, this is a few things. Now I want to show you some examples. Some use cases, what you can do with it, and then we do some exercises, and you can do something yourself. Then maybe things get clear. So if you have a question, you're always encouraged to raise your hand. Yeah, typically the bigger the crowd, the fewer questions. Yeah.
Still not understanding the motivation for storing something in the files. Maybe because I haven't seen the examples.
Yeah. No, the thing is, it goes through the class, and it's designed for storing the class. But sometimes you want to store an instance, you have to go through these hoops to store an instance here. So I'm not really sure why it's not. It's just that's the way it is implemented there.
So is it more like a remote storage? I mean, still not motivated.
Yeah, it's more. Yeah, I will show you one example. So I have one example like calculating a price with BAT, which will be an exercise. I might get clearer why it is, because all the prices will have the same BAT. You can have a lot of different items with prices. They all have, if they're from one country, they have the same VAT rate, for instance, or sales tax rate, you will call it here. Yeah, something like this. That's maybe a good example. Using this instance thing, I just want to show you, you can still do it, but it's actually designed to have things. It's like a class attribute. You know, you have a class attribute, and then all instances share this class attribute, and that's how it works. That's the original thing. But if you want to store an instance, sometimes it can be useful to do it, store it in the instance. Good. So I have a few examples what you can do with it. Yeah. So one of them is actually one example, and the other one is exercises, which is examples, and I show you the solutions as a thing. One of them is attribute checking. So there it is. Checked. It's checked. So this is a checked. Check conditions attribute. This can be useful. Actually, I use this weak key dictionary thing here to store it in the instance. So I can check attributes for something. Actually, the user can supply a function that helps me to check it. So there's a few moving parts. So the problem is you have to read through the whole thing first and then maybe read it again to start to understand it. Here, what I'm doing, I have this descriptor, and this takes an optional checker in the default. And if there's no to checker, if there's a checker, it calls a checker on the default. We see in a minute, but the checker is this user supplied function that's doing something, and it's doing some checking, and then it sets a checker on the default here. And then this is just here getting the value, and here this is where things comes from. When you set it, if you have a checker, it will use a checker to check the value for some condition. I don't know what condition the user will supply this function doing something, and then I set it. Okay. Next step, I can write our own checker, and this is a very simple checker. This just checks if something is an integer. So I get a value, and I just check if value is an instance of integer. If not, I raise a value error. That's my checker. So you can write your own. That's user code here. That's the implementation library, so to speak, and it's a user code. And then I have my class, and now you see what I'm doing. I have attribute 1 and attribute 2 here, and I can check. And the first one I check with my isInstance, and I set the default to 10. And the second one, I don't have a checker, and I check the default at 12.5. And the third one, I try to say, okay, my checker is int, but I set a float, and this doesn't work. This gives you an exception. That's why I have to do it and try accept, otherwise the whole thing stops here. If I set it to an int, that's fine. So this is the first test. So if you run this one, this will work through. And yeah. And then I make an instance, because this one happens here right at definition time of the class. So if I do this here, you couldn't even define the class, because you make an instance if it's checked here when you define your class. And then this checker function will be called. So go through it. This isInt is a checker. So you have this isInt here, and isInt is something, it's not false, so it will call isInt on the value. So if it calls it on an integer, it's fine. If it calls on the float, you get an exception. Of course, I raise an exception. And now I make an instance, and now I can just access this attribute and set the attribute and do this. And I try to set this attribute supposed to integer. Now you see I try to set it to a float, and this doesn't work. I can set it to integer, this will work, but I cannot set it to a float, because when I set it, this setter here is active and will call the checker, which is int. So if you do this, you get this output. So this is something now you can write, if you need to write an interface to some outside thing that actually that's very important, that you have an integer to have a float or something like this, then you can have this this checker function that's doing something. You can check whatever you want. So the user is free to write a function that checks that the value. You can also check it has to be a positive integer between 1 and 100 or something like this. That's no problem. You just have to write this checker, and then you don't have to repeat this code again and again. You can do this. You can make instances of a checker. This would be something you can do here, and then you can write this restricted access. Good. So this is descriptors. You might not have seen them too much. Most of the time, actually, you can get away with properties. So when you can get away with properties, you should properties. Properties are easier conceptually. The thing is, properties, you need to repeat them in every class. See, here I can reuse this one. I don't have to define this property again and again. I can use this descriptor with all the functionality in here, and it doesn't matter if you use it in this class or the next class. I can reuse it. If I have a property is only active in one class. So if you don't do inheritance or anything, you can use it anywhere. That hasn't been the same. You don't have to repeat the property. That's the difference actually between properties and descriptors. So, and this is very often, if you need to have something that checks for some condition or does something this direction, then maybe a descriptor, it's okay. Yeah? So now my attributes are of a certain type because I run it to this check thing. And it happens at definition time of my class. So my code wouldn't even compile. Typically, when you define a class and you import your module, then the class will be executed, the class definition, and then this attribute will be calculated, and then the check will be done. So, and this is something you can apply to your own needs, maybe. Then you have this, how these descriptors work. Good. Do you have any questions about it? No questions? That means you have to, yeah?
I just create some normal attribute. Is the same protocol being used that's then, like, is that implicitly defined if I just say, class, I do food, bar?
So if you have a normal attribute, no, it checks if it has a get. If it has no get, it doesn't go through. Yeah, so it looks for this get. So if there's no get, there's nothing to call there. Yeah? So the tip is, if you have a normal instance, it looks in this dictionary of the instance first, unless you have this attribute has a get, and then it will use a get. Yeah? Otherwise, it's just a normal dictionary lookup in the instance dictionary, and then if not, goes to the class dictionary. If you have a descriptor, if you have an attribute with this get or set, then it will go to this extra step, and then it will use a descriptor protocol. Unless you have a get attribute method, which is even stronger and just intercepts everything. You won't even get this a descriptor. That's how it works. So the get attribute is first, descriptors are next, and then the normal attribute lookup is the last, typically. Yeah. And then if nothing is there, you can use get to do whatever if there's no attribute of this name. Good. More questions? No? So if you have no question, you have to do exercises, but you do something. So I have 3 exercises. So hopefully they are a little bit bigger exercises, and just you have something, just ask me questions. So write some classes, descriptor that only allows positive numbers to be set, and just make some examples. And then extend it this to decimals. Prevents the deletion of this attribute is fine. And the last one, number 4, this is a descriptor that is VAT, so think sales tax. So you have a net price, and then you have a price including tax. And then this one you can be done with a descriptor, and then you can make classes for different countries or different states with different tax rates. And then each class would stand for one tax rate. And then you can make access to things, and then you will get the full price or the price without tax. And this would be interesting. That would be an application here. So try to solve this problem. You might think through it a little bit. You can take, of course, all the material we have here, and you can just pretty much adapt these descriptors we have here. So typically it's a data descriptor. So with a get and a set. And if somebody sets a net price, you will have a full price, for instance. So I will show a solutions after a while, but right now, so let's say we have like 15 to 20 minutes for the exercises. So please try to do something. If I have questions, I will ask a question. If it's interesting enough, I will turn on the mic again, and then everybody will get the information about the question. So, who's already finished? One. Oh, it's a minority. It's only one person. So, who has finished number 1? Pretty much everybody, yeah? Number 2? Oh, number 3? Only number 4. Okay, so I'll give you another 5 minutes, and then it shows the solution. So if you have a question, just ask me. Okay, here was the question, why you have the bother with this weak dict reference stuff here. The thing is, if you store in a reference to, and you can use a normal dictionary to store a reference to an instance there, you create an extra reference. So if somebody deletes the instance from outside, then your descriptor holds a reference and keeps this object alive. but it's actually not usable from outside anymore because the only reference is inside your descriptor. Nobody's to get it from there because you're not supposed to get in this dictionary from outside. It's a hidden one. So then you would potentially create some memory leaks because a lot of people delete these instances. They think they delete it and remove it, but you keep a reference alive. That's why I use this weak key dictionary. Okay, let's have a look at the exercises. So I will provide all the solutions afterwards. I will zip all the notebooks I create into the solutions and will upload it and will email you. If you didn't get an email, just come to me and I'll give you my card. You can send me an email and I send you an email back. So I had 88 names in this interface and I clicked all of them, I'm pretty sure, and sent out an email, but some of you obviously didn't get an email. So if you didn't get an email, just come to me and just send me an email and I can send you something back. So everybody will get the solutions and also my notebooks. But I just did pretty much what's in the handout here. Okay, this is one of the solutions. You might have a bit different solutions. There might be variations here. This is positive only number. So you can set initial value, set it to 0 here. And the get doesn't do any special, just returns it. And then the set. So I have this here and I just... if you work with Python 2, unfortunately Python 2 you can compare strings and numbers. Yeah, in Python 3 it doesn't work anymore. So Python 3 is a better language, and therefore I just check when I get the value if the absolute value is if the value is not equal to absolute value, then it's not a positive number. So it's a different check for the positive number because you could if you just compare with 0. Then you can compare. Of course, you can check if the number it's actually an instance of a number. That would also be possible. But if you check this one, then a string in Python 2 would slip through. So, and if this is not the case, I raise a value error. That's all. So I can only set positive numbers. It doesn't have to be necessarily integers or floats. It just has to be something that works with ABS in this case. Complex numbers wouldn't work, I guess. Yeah. So and then you just set it here as an attribute, and then you have this one. It didn't bother with any this other things. And now if I try to set a negative number here, if I do this, I get an exception. Just as to give you a feel. Now if I try to set a negative number, in this case, this here. If you comment this out, the next one would also raise an exception because now if I would put a string, this is also not a positive number. Now you get an exception. Only positive values are allowed, got -1. And if you comment this out, so you don't set a -1, then you would get here also an exception because now you got, actually here you get an exception earlier because you try to make an absolute value of str. So this is another filter, you only get values in that you can have an ABS on it. That would be just, you might have a bit different solution, but that's something you can do. Now you can restrict to attributes to be positive values. Pretty easy way of doing it. If you run this thing in production, you might find some more corner cases where you want to do something else, but this is the principle that works here. Okay. Let's load exercise 2. Unless you have questions, always raise your hand. Sometimes I'm not looking. Yeah. I didn't understand it. Can you repeat again?
Within the context where you return the string of only positive values are allowed, could you actually say this, like, could you make the help more point to actually the attribute name, like attribute needs to be positive?
The question was if you can have the attribute name. I think we had the same question here, and I don't think it's possible. So so I can just say that you would say something like value. You want to have this name in the message. I don't think it's possible because an object cannot know its name because there's no its name. An object can be reachable via many names. So you can have as many references to an object as you want, and every reference is a name. So it doesn't have a unique name. There can be hundreds of names. So which one is the one? So you would need to write it in a way. Sometimes you see this. You would need to supply the value something like repeat the thing here. This would be one way. So then you have double information. Now you would give the name value to, of course now I have to change my my positive only and have to put here my name, something like this. Yeah, name and self name equals name. This would work, something like this. You could automate it maybe with a meta class or with a descriptor. That might be something. So now I can use this information here. Only values got positive, only panels for. Let's just move it down here so you can see it better. For are allowed. So yeah, now use this format. Use the old format.
If you use SQL Automate, it seems to be able to.
Yeah, but they use a meta class for this. So no, the descriptor itself cannot do it. You can do this. You might even use it with a class descriptor, class decorator, but you have to do something. That's what I'm doing manually now. The meta class is doing automatically. Yeah. So something like this, and now it should be possible to do something like this. So if I have made it some typo somewhere or something, I should give you this information. No, and this one doesn't get there because the exception is earlier. But if I take this away, name, self name, yeah, self name. See, I knew I made a typo. Whoops. For value. Now this is a value. Now it works. Yeah. So now you can do this. You can use name. Yeah. So you have to make it explicit. That would be the easiest to make it explicit. Just hand it as a string. Otherwise, you have to find the other means to get this information in. And the meta class would certainly work because the meta class can go through this dictionary and can find this name value. And then, because you don't have to put it in the init here, you could set it later or something. That would be possible. Yeah. A special function to set it later. And then meta classes there would be, at this moment when you actually do this here, a meta class can get in and can get this information there as a dictionary. So the value, it would be a string in the dictionary, and this instance would be the value. The value would be the key, the string. The left hand side and right that would be possible. And you can even do it with a class decorator. So you can check. You would check if this one is an instance of this descriptor, and if it's a descriptor instance with some whatever you want, then you can do it. So you would distinguish between other attributes. Yeah. There's more to it maybe, but this would be the basic thing you can do. Okay. Load exercise 2. This was easy, I think. Hopefully, I remember right what I did here. So, and then you just add here a rounding. That's all. That when you say get, then I just down the get, I've just round the value. So you don't want to store it round because you want to have the original value around just in case. But now if I return it, I get it rounded to 2 digits. So now if I supply a number with many digits here and I print it out, I get it only with 2 digits. Yeah. Be aware, round changed a bit in Python 2 and Python 3. So if you have like 2.5 rounded, I don't know if you knew this, if you have round in Python 3, and if you do this in Python 2, you get different results. Yeah. So you have to be aware of this rounding. Rounding will change. So it's if it's an even number, always rounds to 0.5 to an even number. Yeah. That's why it rounds it there. That's how I learned it in school actually, round to an even number, but there are many different rounding rules around. Okay, now exercise 3. So, and now I just have this delete here, and I just over a delete. That's something you can also do something, some other action, and just put it there, and then something happens when people try to delete it. I get my message, or I have my action. You could do something else and just write a message, whatever you want to do. Okay, the last one is maybe the a bit bigger or more interesting one. Load exercise 4, And here, so you can use different states. I use countries. Typically, I'm from Europe, so we have European people talking to, but it doesn't really matter. So I have this total, which has a rate here, and this is a rate for Germany, by the way, so where I'm from. So I just use it as a default, but you can use any other rate. So we have 19%. In Europe, you go from as low as 3%, some places, for some things up to 25 or so, big wide range. And then here I have this question was what owners actually the class here. And then I do the rounding, and I have my net price, and I multiply my net price by the rate. So this rate is supposed to be 1 dot period dot something, so more than 1. And then I round it by 2. And setting is not implemented here. And now we make different prices. You see, you can do something like this. You can use inheritance. So I have a price here. So I don't have to override the init all the time, which sets the net price to net, and then I have a price for different countries. Germany has 19%, Denmark has 25%, Luxembourg has 70%. It's the lowest for the general rate. There are sometimes a reduced rate. So now you have different classes, and they have total rates. And now if I access these things, you see I make instances of these classes, and I print the total for 110 euros. Yeah, I think, no, Denmark doesn't have euros. Do they have euros? I'm not sure. You can do something, and you try to set it doesn't work. But if you do this, you will always get a different rate. So depending on the VAT rate, in this case, you get a different total price. And now you see you can make many instances. All instances for one country have the same rate, but you can have different instances. That's what makes sense. Now you have one rate stored here. This rate is stored in the class, and now if you make instances, they all get the same rate. And if you access total, you always get the total number. That's something you can do. Yeah, so you can make as many instances as you like down here. You can have another instance with a different price, but the rate would be fixed in the class. And that makes sense. So you might be able to apply it to something else. It's just an example, but you might be able to transfer this kind of thing to different applications. Good. It's exactly 3 o'clock. So this was the first part with descriptors. So I teach this part as an advanced Python course, and some people find the descriptors more difficult and some the metaclasses. So you can decide yourself after the break which one is more difficult and which one is more useful. The metaclasses gives you maybe a bit more leverage what you can do. Yeah, but might be a bit more difficult to understand. Depends how you think. So we have 20 minutes break. There will be some drinks and some food outside. I would ask you that we really start in 3:20 again. So if you try to be here like 3:15, something like this, so we can really start, because the metaclass topic is a bit bigger than descriptors. I think have more examples, so we need the time. So just take a coffee, get some energy, get something to eat, and then we continue here sharp 3:20. Problems. So if you have more problems, I'm going to stick around after this tutorial. So we're supposed to be finished by 4:40, I think. Something like this for one half. Yeah, something like this for 1.5 hours. Would be 4:50. And the next thing is actually the reception, 6 o'clock, so there's some time. So if you have any more questions, you're welcome to, after the tutorial, come to me and show me your problems if you have anything. Something didn't work. I cannot promise that I can solve for the problem. At least I can give my opinion. Maybe I find something. And if you have some other more practical thing what you might apply one of these things, I can have a look if you're interested. Good. So we did the first part, descriptors, which is supposed to be the easy part. Depends. Some people said descriptors are more complicated than metaclasses. One of my classes, but typically metaclasses is just the name already is a little bit kind of meta, strange, to indicate that it's more difficult. Hopefully it's not that difficult after this tutorial, and I will show you a few things and actually have quite a few more examples what you then do with metaclasses. So metaclasses are to classes what classes are to instances. If you understand this one, this will be 50% of the solution of the problem. So if you have a class and an instance, this is pretty much the same relationship as a metaclass and a class. So you'll see the syntax, other things are very similar. There are a few tiny differences about inheritance and stuff like this, but pretty much it is fine. This lets you control what happens when a class is defined. So you're pretty early in the process. It's similar actually to what this class decorator can do. So you might know since 2002.6, you can use class decorators, you can decorate the class. There's similar types of things you can do with a decorator. With a metaclass, you still have some advantages in terms of what you can inherit stuff which you cannot do with a decorator. We can look at it quickly. So for instance, ORMs, so somebody mentioned SQL Alchemy already, so SQL Alchemy is using metaclasses. There's a few tasks that is very nicely solved with metaclasses. But also can be a nice exploratory tool. So if you want to know something about your code, and actually they have a few examples so you can dive in and see what's happening in your code, and you can use metaclass with it. So metaclasses in the wild, so I have two examples. Django's use metaclasses and SQL Alchemy. There might be a few other ones that use metaclasses, but these are probably the prime examples. And no, that's the last slide. Go back. So let's have a look at some examples. So I make a new notebook so that we don't mix it up. I make a new notebook and call this metaclasses, and then we work with metaclasses. So actually the beginning what I have here, the difference between a new style class and an old style class, I can only show with Python 2. So actually I have to make a Python Python 2 thing. Let's call this motivation, where it comes from. So if I make a Python 2 cell here, and I define a class old, which is just something like this, and the class new, which is inherits from object. So as I said in Python 3, there's no distinction. So I have only these two classes, and that's the only difference. And now if you actually print the type of both of them, so of the new class, type of the new class, of the class itself, and then the old class. So you see the differences between an old and a new class, and then you see something different. You see, if you have a new, you get a type. That's what you get always in Python 3. If you have an old one, you get a class object. So it's not recommended to use old style classes because, as I said, descriptors don't work. And everything you do with a metaclass always doesn't work because there's no concept of a metaclass in this case. And if your other things might not work with old style classes. So always use new style classes. If you still have to work with Python 2, if you work with Python 3, there's no choice anyway, which is a good thing because you want new style classes. But in Python 2, actually, you can do something like, if you want to, you can define a new, we're still in Python 2 to see the differences, Python 2. You can have a class new2, which doesn't inherit from object, but it has this meta class attribute, and the meta class is type. And when I do this, now I print new2, and I look at the type of new2, then Python 2 has to be 2% signs. And then you see it's also type, because this is a meta class. You can set the meta class by setting the underscore meta class in Python 2. In Python 3 is a different syntax, we'll see in a minute. or you just inherit from object, because the metaclass of object is type. And therefore, when you inherit from something, you get the metaclass of your parent class. That's two ways. So typically inheritance is easier because people know about inheritance. And that's also, we will see later on, even if you write a metaclass, people don't even know because you just give them class to inherit from this class, and then they get your metaclass without bothering with metaclass. You don't have to mention, don't scare people with metaclasses. Just say inherit from here, and that's it. So that's one of these things. And it looks into this metaclass dictionary and finds it there. Otherwise, it looks into basis. So you have this basis, and inside basis you have you can find this metaclass. You can also actually in Python 2 again, you can define. This is just a hack to change the metaclass. You can set the metaclass in a module. In this case, just in my cell. So this cell just represents a module, a file. And now, if I have this news3, if you want to call it like this, and now you can do the print news3 and news3. Just copy this line and change to 3. Then you will see is also type. So that's a possibility. Just if you want to convert some old classes to new metaclasses, just the first thing in the file you say metaclass is type, then every class that doesn't inherit from anything and doesn't set a metaclass will get your metaclass. But it's Python 2 only, so in Python 3 that's not necessary. Okay, this is the motivation. And now we're still not really into the metaclass topic. I want to show you how to make dynamically actually classes dynamically. Building classes dynamically. So that's something you can do because there's nothing special. So instead of saying class A that inherits from object, just set the simplest class that doesn't know anything. You could achieve the same thing saying A equals type. So the type has different options. You can use type to find out the type of object, but you can also use type to define a new type, and the class is nothing else but a new type. And you just have to define the name. So this one, you should use the same thing, otherwise you just the same string here, because Python will actually introduce a string in this place. And we talked about having the string. We'll see that that's possible with metaclasses. And then you have a tuple of the parent classes, or the base classes, which is in this case just object. A tuple with one element has to have a comma. And then I have a dictionary. So I have a dictionary with, where's my dictionary? Ah, yeah, so let's change this. So I have this different example, not pass. X equals 1 in class attribute. It doesn't matter. And so here I have a dictionary with X 1. And this is exactly the same. You see now I have a class A, X. It's exactly the same. Both are totally exactly the same. So you can always build classes dynamically. You shouldn't do it if it's not necessary, because it will be, you can produce code that is really very, very different to comprehend for humans what happens. Python doesn't matter. If you type it like this or just make it dynamically, it doesn't really matter. So you could even do something like this. You can define your methods. I can define an init, just right here, not inside the class, just here, right here. It doesn't have to be an init, which is doing something. Self, let's call it X, it's just different names, it doesn't matter. You say self X equals X. So I have this method, I have another method here, just see what I have, it's just example, and have a next one, add, for instance. Def add self A and B. So I don't access the self here, but it doesn't matter. It's just to show you that you can do something. Return A plus B. And now I can use these and put them into a class. So I say C is type, name C. Makes a lot of sense to use the same name. It doesn't have to be, but it makes it more difficult to understand. And then I have my object tuple inherits, and now I have my dictionary, and inside this dictionary I just put the names, and of course it makes a lot of sense to use the same. Init is init, you see, and init, and add is add. So once a string. And now I can make an instance of my class C, and I have to provide a value, x, 10. See, now this works, and now I can say add 4 and 5 gives me 9. So instead of writing this in the class, you can have this. You can have them in a different module and import them, and you have these functions, and then you put the functions in there, and you can assemble class and runtime. That's pretty powerful. Yeah. But as you know, with great power comes great responsibility. If you do this extensively, this will be very difficult to read. So you just import the function from there and a function from there, and then somewhere you put it together and make a new class. It's really difficult to debug, so you shouldn't do this. So if you can just use a different normal way, just write a class. This is only necessary if you need to do something dynamic. If you don't know, then you program, but actually will be coming. Like SQL Alchemy is a good example. SQL Alchemy is just representing SQL tables or database tables somehow, and they don't know actually what column they have, whatever. That's why you have to be pretty dynamic, because you want to represent this one. And you don't know really what you will get right now when you program it. Then you might need to something like this. But this is just how it works, and you can assemble a class at runtime if you want to. That is not really a problem. Now, let's write a meta class. So we can write a meta class ourselves, and writing a meta class is actually very easy. So we write a new meta class, and the only thing you have to do, you inherit from type. Typically, you inherit from object, then you get a normal class. If you inherit from type, which is one level higher, then you get a new type. Makes sense. If you inherit an object, you make a new object, new class. Here, I inherit from type and make a new type, and I can do something, and to show that I do something, I override str in this case. And here, of course, I'm one level higher, so instead of self, I use CLS. Theoretically, you would be free to use any name you like, but it's highly recommended to use CLS. So always highly recommend to use self, and here CLS, which stands for class, because the names are important, and you should make it as simple as possible in terms of names. For you, Python doesn't matter if you call it A and double A and 3A and 4A, but you call it class here, that's a class. And now you can return something, whatever you want to return, doesn't matter. And now you can make a meta class. So here I have the syntax for Python 2 actually, but for Python 3 the syntax is different. So I have a class, B, and in Python 3 you say meta class. Meta class equals a new meta. This is the syntax only for Python 3. That's a new syntax. I'll show you in a minute how to do this in Python 2. And I don't do anything. And now I have B. This is a representation, but if I create strB, then you get works. Yeah? If you have an str from another class, one of the other classes, you get something like this. So I can change what happens if I call str. Yeah? It's just overloaded. Yeah, this is a special method for when you convert something to a string, this method will be called, and now I convert it to a string, or if I print it, it's the same thing. And this is a standard if I don't do anything, but I can override it, and now every class that has this meta class will have this new str. You can do something more useful, but you see how it works. If you're in Python 2, then meta classes are a bit different. So in Python 2, you have to do something like this. Python 2. So you define your new meta class, and then you don't have this syntax. This syntax doesn't work at Python 3. There's a really hard syntax change, which is kind of tricky to write single source code for Python 2 or Python 3 if you use this. So you don't do this, you do the following. You use this meta class underscore thing. Oops, meta class. Something like this. And now if I print my B, then you will see this new. You see now it works. So this would be a different syntax in Python 2. There's a hack, actually, there's a with meta class thing, which is pretty complicated, that allows you to set the meta class in Python 2 and Python 3 with the same code. Okay. Fortunately, setting a meta class is not that often. Typically, you set it once and then you start inheriting from this class, which is typically the preferred way of doing it. Good. This is what a meta class can do. Now you can change the behavior of a class. Yeah, a class changes the behavior of an instance. Now you can change the behavior of a class. And let's look at something more practical, what you can do and how things work. And very often what you do, you want to do something when somebody creates a class. And there are two special methods you typically work with: the init, you know the init, but there's also a new. Normal classes also have a new. You rarely override the new. So the init is not a constructor, actually. It's just, that's why it's called init. The instance already exists. The init takes self as a first argument. Yeah? But the new is before the init, and there the new actually returns a new class. A new instance, sorry, for a new class. Yeah? So you rarely override new because you don't need to. And I would recommend not to override new if you don't need to. You always use init, which is a common thing. But when you write meta classes, you likely more often to actually override the new. So let's see how this new and how this init works. So I make a new meta class, my meta class, meta, which inherits from type. And now I override this new. So I override the new first. So you will see there's a difference between init and new. Init is always okay if you just want to get access to something new, when you actually want to change something in this class. So this is special new. And now the first actually argument is not even class, it's a meta class. I call it MCL for meta class. So, and then you get the name. The signature has to be the same, otherwise it's not going to work. So name, the basis, the tuple with a basis. This is very similar to what we just had. And then you get the class dictionary. So that's a new. And now I just print it out, just to show you what we have here, and I just echo things back. That's all I'm doing. So a meta class and stuff like this. So you have this meta class. I have the name and so on. So you see what's actually coming. Basis is a tuple with base classes, and a tuple very often is only one. So of course then basis is just has this comma inside. Basis, and then the dictionary, the class dictionary. So all the names are always stored in dictionary. So knowledge of dictionaries is very important because you always have to access dictionaries. So, and then you have to do return. So init never has a return, so never put a return in init, it's not going to work. Here you need to return something, and I say super. So if I would be in Python, even Python 3, I can keep super empty. That's a very nice thing. So super with parentheses is fine. In Python 2, you cannot do this. You have to put in my meta. Actually, you can do this in Python 2 if you use this Python future org library. Then you can import a new super. Then you have a backport of the super actually. But if you don't have it, then you have to put in my own class. It's the same thing. Yeah, my own class and self. And in this case, self is MCL. It's a bit strange in the meta class, but I get this argument. And I have this, now I have to call it with the same signature, name, basis, and cdict. Basis, cdict. Yeah? So a new always has a return, and you have to actually return the instance. The instance doesn't exist yet, or the class in this case doesn't exist yet, and I have to return it. Whereas with the init, there's never a return, and you get as our first argument. That's something you can do. And now, of course, I make a new meta class here. I say class is my class, and I say meta class equals my meta. So if you do this in Python 2, you have to do the other syntax that I showed you with the underscore up here. Python 2, you have to do this. That's a real difference here. And that's it. And you have to put a pass here. So otherwise, you do the next. Super takes 2 arguments, 5 given. Yeah, so the super has to finish here, and I have to call the new of the parent. So I mistyped it. So, yeah, that looks much better. Super new.
You need MCL as the first argument.
New MCL name.
Yeah, I missed the MCL. This it has to be there twice. So it's exactly the same signature as up there. Yeah, yeah, the same signature as there. So if you manage to type this what's there, then you get this. So that's a typical thing. You have to have the same signature. So you have to do this, and now you can intercept. You can do something here. You can actually, we'll see the next step, you can actually write something in cdict, and cdict is just a dictionary. You can actually introduce methods here, or change methods, or do whatever you like. So you can change the class here at definition time. Yeah, so this call name you won't see in Python 2, by the way. That's new in Python 3. It's a new attribute. So there's new attributes here. If you use init is very similar. So I just copy this in here, see if it works. The init is similar. I just show you how that works, and then we do this. So the init is very similar. Only there's a few differences. Init gets the class as a first argument, not the meta class. That's a difference here. So you have a class, not a meta class. The rest is the same here. So it is a class. And of course, you don't have a return. You don't have a return. You just have a super call. There's no return here. There's no return. And this has to be the class. And this is the init. And the init is called without the first meta class thing. This is totally equivalent to new when you use new with classes. So this is the init. So you see, here I have the class already. I cannot modify anymore the class. I have the class, but I can access the things that are in there if I wanted to. And now I have to call init. Whereas here, I have the meta class, and I return a new instance of a class, or a new class. Instance is maybe not the right word. Yeah. Okay, that's a slight difference. Otherwise, it's the same, very similar interface. Okay. And you can do this, and then you can intercept it, and you will see that something happens. Good. That is a technical part, what you can do. And the difference we'll see between init and new. I would always recommend init as long as it works, and only use new when you need it. That's my recommendation, because init has less powers than new. So if you can get away with less power, then use less power, I would say, because you cannot make too much damage if something goes wrong, typically. Okay, now I have something to show you how to support Python 2 and Python 3 at the same time. This is something that's a bit harder to understand. You need to understand, but it comes from Jinja 2 actually, and is used in SQL Alchemy, and also this Python Future Org, what I told you this thing is. And there's some imports here, and there's a long doc string. So this is from Jinja 2. I just took it from there, and this is his code. And you can read it 3 times or 5 times, and maybe understand 50% of it. This is doing a lot of trickery to actually make it work, and then you can use it's the same syntax in Python 2 and Python 3 to apply a meta class. So you don't have the distinction between the syntax. So you do something very strange, and this is kind of replacing itself as calling, or I don't know, it's doing something. But the thing is, when you use it now, you see you can use this syntax. You say with meta class, and you put the meta class here and then the base classes, and this syntax works for Python 2 and Python 3, that's all. So you don't have to understand how it works. And then you can use the same syntax for Python 2 and Python 3. So if you need to write single source for both versions of Python, this would be a way to go. I just put it here, and I've used it in several places, and you can do something with it. Okay, now I have a few use cases that might give you some idea what you can do, maybe some inspiration. You can do a lot of things with meta classes, and I played around quite a bit, and I tried these and this, and I give you some suggestions what you can do. So the first use case is classes with methods only. So, or you can also say there's no class attributes, no attributes that are not callable. So I want to have a class where it's automatically enforced that all attributes have to be methods. There cannot be any class method which is a string or an integer or something else. It's not callable. And you can do this with a meta class. Actually, you can do this with a class decorator. With a meta class, you can do inheritance. Okay, this gets a bit longer. Not that long. That's the whole thing. So I used this. I define a new class attributes meta class which inherits from type. And now override my init. Here, the init is enough. Every time you just want to inspect something and then want to raise an exception if something goes wrong, typically init is enough. If you really want to change something, you need to have override new. So init takes class name basis dict. So I want to forbid ones, but I want to allow a few of them because those ones that Python sets automatically. The module, the meta class, the doc, and the qual name, and maybe some more. If something new come out, we need to add it here. The qual name is Python 3 only, meta class is Python 2 only, but it doesn't hurt if I put more. You can put whatever, just they are allowed. Then these names will be allowed. They are allowed to be non-callable. Okay, and now I have this power. I have cdict, which is just a normal dictionary. So very easy. So you can apply all your knowledge of dictionaries, and you can do something. And I just go through the dictionary, items, and get the key and the value, and now I need to just check. So if the key is not in allowed, so I use a set here. It's not necessarily a set, but typically when I look up something, I use a set. If it's not in allowed, and if it's not callable. Though there's this built-in callable, which was disappeared in Python 3.0 and came back in a later version for some reason. So callable is, I think it's not 100% foolproof that it always works. I think most cases it works. That's my understanding of it. You can also use other methods, like check for the attribute underscore underscore call underscore underscore. But I use callable. So if it's not in allowed and not callable, then we have a bad case. So it would be a string or an integer or a list or something. So something that's not callable, and it's not one of these. So if the name is not like this and the data type is something that's not callable, then I want to make an exception or raise an exception, and this just assembling the message here. So found non-callable attribute with its name, only methods are allowed, and raise the exception. Okay, now when you apply it, I use my famous here, this meta class, so I can work. Now this code works with Python 2 and Python 3 at the same time. And I use a meta class for this one, and that's fine. Attributeless is also fine. And here I have a class as attribute. This is not allowed. You see, I don't want to allow this. This is a class attribute that is not callable. And this is not allowed, and if I do this, it will not compile. When I import this, you get an exception already. So you won't even be able to run it. Yeah, because at the moment Python goes through and reads in the class, it will get through it and will feed this dictionary with the key A and the value 10, among others, into my meta class, and then A is here, and I have the 10 here, and I can decide, okay, A is not allowed, and 10 is not callable, and therefore I get an exception. And if you run this one, you get an exception. So this one works from attribute-less here, and you can call the method. But here, if I want to make this, I get this exception. Found non-callable class A, only methods are allowed. So you could make it so A of type whatever and value 10 or something. You could have more information if you like. This is just an example. And that's something you can do. For whatever reason, now you can forbid non-callable class attributes. Yeah? That can be pretty useful. And this will work with inheritance. So if you make one class that has this meta class, then every class that inherits from this class, as long as you don't use other meta classes in the way, which is difficult, it doesn't really work. If you use multiple meta classes, it's a bit problematic. Then you get an exception here. And this is pretty useful if frameworks do this. SQL Alchemy is a framework, Django is a framework, more or less. If the user is writing them code and the framework is calling this code, and the code has to adhere to some standards, and one standard could be that cannot be a non-callable class attribute. And you can check it right at compile time, they won't be able to compile. There's nothing, the program will never get to run anywhere, because the moment they import the module where the class definition is, you get the exception. So it's a different time, because a bit earlier here, the whole thing. Okay, this is meta classes, and you can do quite a bit of these things. You can achieve quite a bit of the things you can do with meta classes with class decorators. So let me give you an example with a class decorator. As I load, what's the thing? Class decorator. So you can achieve the same thing here with a class decorator. It's the same thing done with a class decorator. So a class decorator is just a simple function. A class decorator is a simple function that takes a class CLS and returns the class CLS. And in between this, doing the same check. So the logic is the same. So I have my allowed, then I have key value, and I can say, okay, class dict items. Remember the dict? So the dict is just this dictionary. And as long as you need only to do things you do in init, you cannot do things in new, because the class decorator will get an existing class. It will never get the meta class and produce the class itself, like the new. But whatever you can do in init, you can theoretically or practically also do in a class decorator, and that's what I'm doing here. So I achieve the same thing with a class decorator. Now I have to, of course, decorate every class with a class decorator. And now I get exactly the same effect. You see, it works exactly the same effect. Yeah? The only difference is I have to apply this decorator to every class. And if I inherit from the class, it doesn't matter. Those decorators will not be inherited. They don't pass down to the children. Whereas if you do with a meta class, if the most base class, the base class of everything has a meta class, everyone else will get the same behavior. That's a difference. But typically, the class decorator is a bit simpler. So you don't have to dive in all those meta class things. This just get the class, and you return the class, and you do something. And there's nothing special because the class is a dict item, so you have all the attributes of a class in there. And that's it. So you will hear very often that you can use a decorator instead of a meta class, which is true in most cases. Okay, now I have a bit more complex example that's doing a bit more, and this one actually needs a new, because now I want to only get information out here. I just get information out of this dict and use them and do something on it. Now I actually want to modify the dictionary, and to do something I use something like this. I use slots. So, are you familiar with slots? So slots it's something actually, the main purpose of slots is to save memory. So of course if you make a lot of instances of class, every class has a dictionary. And the dictionary is quite expensive with the memory. So if you put the same data, you have a list in a dictionary, you use 3-4 times as much memory or something, because it has key value pairs, so the first thing. And the second thing, the dictionary can only be not more than 2/3 full and will be resized. So it takes quite a bit more memory. So if you have a lot of small instances, like say millions of instances, all these dictionaries take up quite a bit of space. Then you can use slots. Slots you don't have a dictionary. It's just similar to a dictionary with like a key-value correspondence, but you cannot add new attributes at runtime. So with a normal class, you can, this is a dictionary, you can add something later on. The slots you cannot. And I use slots, and I used a descriptor. I put everything together. I have this type descriptor here that is just checking for time. So it's a bit more involved descriptor. And then we use a descriptor and a metaclass and slots together. So it's a bit longer. Let's go through it slowly and then come again. We see how this, what we can do. So have this type descriptor that gets a name, an internal name. We see what is good for in a minute. Then we have a data type. And if it has a default value, that's a default value. Otherwise, it doesn't have default value. It just calls a data type. Like if you call int, you get a 0. If you call list, you get the empty list, and so on. Get attribute is easy. You just use an internal name here, a default value to do this. And then we have a set. And if it's not an instance of this data type, I raise an exception. So I guarantee that only values with this data type can be set. Otherwise, I set it. Okay. And now I make my method class. Yeah, you see this. Here you have your type. So we will come back to the descriptor in a second. So I just need it here. And then I automatically add slots. So if you have a class with slots, okay, maybe I explain slots a little bit more. So if I have a normal class, A, so inherit from object or not, doesn't matter by in Python 3, then you can, that's a normal class, you can later on add new attributes to the class. That works. If you have a class B that has slots, so this looks like this, slots, and slots is just a list of names, for instance. I have A and B. Now I can say A, yeah, A is there, and I can set the value to A. That works. But I cannot say X. Can I say X? I cannot. I have to make an instance, sorry. But I want to make my point, and it doesn't work. So you can have A, just that to for the, make a new class, and get rid of this first. So I can set A, this works, but if I want to set X, I get an attribute out. So if I do this with A, so just I define A again, and I can make an instance of A. Yeah, and now I can say A dot X equals something, and there's no problem. So I can modify the instance at runtime. If I set slots, I cannot. I can only use the names A and B. So you're restricted. So this saves memory. So if you check the memory footprint, this will be less memory. And you also restrict, you cannot add anything later on because it's not a dictionary, it's a different storage mechanism. So when I use slots, then it because it also gives you the property that it can add any new things at runtime. Okay, so that's what I'm doing here. So I set the slots by hand. Now I do it automatically. That's meta-programming. Now, what I used to program, now I use a program that does it for me. And I just go through here, this new. I have an empty list of slots. I go through the attribute and the value in my dictionary that we know already. And if the instance is of type descriptor, so if it's one of these descriptors up there, then I do the following thing. I go and take the value name, set it as attribute. The internal value is some underscore attribute, you'll see in a minute. And then I append to slots. So slots is a list I append. So I actually add this to the slots. Only these are allowed. Won't be able to do anything else. And then I actually set this underscore slots. You see, this is the same thing as defining slots here. This is the same thing as adding it to the dictionary. And then I actually call my super with the same thing with new. And that's it. Then I use meta 2 3 to make it work with Python 2 and 3. And that's a usage. So that's pretty complicated, but usage is easy. And I see what I'm doing. I make one base class typed, which uses a meta class syntax. And from now on, I don't have to buzz up the meta class anymore. I just inherit from typed, and they get all the meta class. And that's a typically recommended way of doing it. Make one meta class, one base class that then has this meta class, and then you don't have to tell the user use a meta class, because they might not even understand what the meta class is. They don't need to understand necessarily. You just need to know they have to inherit from there. And I make attribute 1, which is an int. Okay, let's look at this int and float. Let's look at this thing again, what it means, because I'm in the descriptor. This is a data type, and this is default, which is optional. If not, this will be none. Yeah, see, it's int, and this is value, which is optional, as I said. Int will be produces 0 because I call int here, and this is float is 5.5. This is fine. And now I can work with this. And now if I want to set an unknown thing, which would be possible with a normal class, it would be possible. Just come up with a name. Here it's not possible because I have slots. They set the slots for me. So the user here doesn't have to work with slots. It just has to use these 2 descriptors there. Inherit from typed to get the meta class and use the descriptors. And now it would work like this. If I run this here, I make this instance of the class. You can print the attributes. You can list the attributes. And you have the slots. I can set 100, but this one would fail because I cannot set 100. See, I have this my 2 slots. I use an underscore here as an internal name, so it's already internal, and they have the 100, and then you can do this. We get the exception. Yeah. So it's pretty restricted, so you can do quite a few things. So there's no way to set a different attribute now, and a lot of things going on, but for the user it's pretty easy. The only thing, inherit from type, and to use these 2 descriptors here. Yeah. And again, this can be simple. You don't have to actually say that's a descriptor. You just say, okay, we have to give an example, and you have to do something like this, more or less. That should work. Yeah? And now it will be checked. This is a data type and with a default value, and you cannot set anything else. This is slots, and this is an example where I need new, because you need new. Why? Because actually I'm writing in the dictionary. This is the reason. I'm writing the slots in the dictionary. If you wouldn't need to write in there, you could get away with init. You can write with init, but it doesn't have any effect. It doesn't help. You can change the dictionary, but it's too late. It won't have any effect. So it needs new. Good. So I have a few more use cases. I have a few more use cases, and here I think I have to distinguish between Python 2 and Python 3. The next use case is counting the number of class definitions. And this is something I tried for a while, and this seems it is not that easy, actually. And there are problems, but there's a good solution in Python 3. Let's show you the Python 2 solution first, which also works in Python 3, I think. But it has a few drawbacks. So I have this, which you call automata. So I actually want to count how many classes are defined in your running program automatically without going through the source code. And that's what I'm doing. I have this debug meta. And actually what I want to use, I want to replace the meta class of all classes you have with my meta class. And then I can do something. So every class that will be touched will go through my meta class, and I can do something. I can count how many I have, and can do some statistics about my classes, which could be interesting, maybe. So that's what I'm doing here. So I inherit from type, and I have a list of names. My counter starts as -1 for some reason, because I don't want to count myself, I think. That's why. I have new object. Yeah, because I replace object, and I have a meta class, which is just have a counter. You see, debug meta is the class attribute here. It's a counter. And if it's greater or equals 0, I just append names from the module and call super as I do for the init. And then I increment the counter. Here, increment the counter. And I have a report class, and I just show how many, it's like small help, how many classes are defined. And now I do a very dirty trick, which I don't want to do here. Actually, I don't want to execute the thing. I define a new object which has this meta class, this Python 2 syntax. And then I go in and go to in built-ins and replace object with new object. This is for debugging. Don't run this in code. It's just a second. Yeah, so you should do this typically, but if you don't run it somewhere, you just want to know something about your code, and instead of grab over code and using some other tools, that might be interesting. This works to a certain degree, because now I replace object, so every class that inherits from object. So assume if you use always inherit from object, which you should do. So if you have code that's kind of decent, it should inherit from object in Python 2. Then I would now replace the built-in object with my object, which in turn inherits from my meta class, and then everything goes through there. Yeah. So it is pretty strong, so it's certainly not recommended for any production thing, but this is a tool for code analysis. You want to do something with the code. And that, I think then a lot of things are okay, because you using this code and then don't give it to somebody else. You just use yourself, and you do investigation. And you know that something could go wrong, actually, when you do something here. So now I have, I think, use an example. Yeah, use this automata. I just show you, but I don't execute it here. Use, load, use, automata. So what I'm doing now, import this one. And I have to call set new meta, that's this one actually, to activate it. So it's not automatically, you have to explicitly import, which is a good thing. And when I do this, now I have, as you can see here, a class 1 which inherits from object, the class 2 inherits from object, and class 3 which doesn't inherit from object, it's an old slide class, it doesn't work. And if I run this, I go to the command line. What is the direct rates? Maybe. Yeah. Okay. If I go to Metaclasses, and I have this use Python use automata. Yeah. Yeah, I'm in Python 3 here. I have to do with this is Python 2 only. So if you do this, now I get 2 classes are defined, and I get actually the list of the classes. So now it's a very simple program, but if you have a more complex program, you know how many classes, and you can find out which classes are defined. And you could go to the list of the class and do something, search for certain names or whatever you want. Yeah, something like this can be done. And this works to a certain degree, but has a drawback here. There's a problem. I have a file problem with this. If I use certain types of things, you get a problem. Actually, you get a bunch of problems. So if I import some of these standard library modules, that's all is fine. But if you import matplotlib, numpy, or skAlchemy, it doesn't work. So numpy and skAlchemy don't work because they use their own meta class, and you cannot transplant your meta class as a most object and then you use other meta class. That doesn't work. So you can have 2 meta classes. They compete with each other, and it doesn't work. You will see that if you change this in Etto and uncomment it, it's not going to work. So I run it. This one should work still. So Python problem. Yeah, you see now I get this long list. I get this 6 to 8 classes defined. If I start uncommenting one of these problematic ones. Oops. Supposed to open here. Why doesn't it open? Yeah, now it opens. So the second time. So if I uncomment one of these and I run it again, then I get this problematic things. The weak slot is allowed. There's something with weak refs. There's one problem, and the other problem, if you have SQL Alchemy, which has a own meta class, then you get this problem. So it doesn't work for all libraries. So if you use some libraries and you get this conflict, meta class of derived class must be non-strict subclass of meta class of all its bases. So this means actually you have these two meta classes, and now I move my meta class to the top, every single object, and then there will be another meta class from SQL Alchemy somewhere in the game, and that doesn't work. And I couldn't resolve the problem. Spent a bit of time on it. It doesn't work. So this is not going to be useful for everything, but it still gives you quite an interesting idea what you can do with it, and you can try a few things, and you can play around with it. So let's put it in the category. Just try and see how it works, but can be interesting. And I can do something with it. Okay, the base conflict, I just show you the base conflict here, why this happens. And I have this base conflict. So just I try to extract this base conflict where they have the base class thing. So that's what I have here. So to make it work with Python 2 and Python 3. And I have two different meta classes. That's what happens. SQL Alchemy has a meta class, and I have my meta class. The meta class 1 and meta class 2. And then I have a base class that has meta class 1 as a meta class, and a base class has meta class 2 as a meta class. And then I do multiple inheritance. That's what happens somewhere down the road. So SQL Alchemy does multiple inheritance from a normal object and from this own class with a meta class. But now this normal object was influenced by my changing the built-in object and has a different meta class, and this doesn't work. So if you try to run this one here, then you get the same exception, just the same thing. And that's what happens here. So if you have this multiple inheritance, you inherit it from two different classes that have two different meta classes, it's not going to work. So the approach doesn't work here. Good. So I have a few, some other attempts with a class watcher. So I use this. Yeah. In Python 3, you have some new things that make things easier. And actually, in Python 3, I could resolve the problem, I think. And I have this thing called class watcher, which is this automatic tool that is doing this. Yeah. So built instance has a bit different name. I do use collections counter here. I have my own exception. And now I don't even, that's a normal class. We are just overriding new. One instance of this class, we have this new, and I go through here, and we can make only one instance. So the instance is this. We have this in here. And what I'm doing, I override the build class. The build class is a special method which is new in Python 3. And they will replace the built-in build class. And this is called for every class that is built, and I can intercept the building of the class. And that's what I'm doing here. And I'm going through and building my class watcher and a few other things here. Just we have to go through step by step. And then I activate it, so there's a few steps here. and I have to do something. Yeah, I can activate and deactivate actually when I have a report. And then the report is just printing something out. That's what I'm doing here. So this is just the class. So I don't use it yet. And then I have a use class watcher. Just we go through this later again because it's pretty involved. Use class watcher. I use it, and usage is easy. So the use class watcher is just to import the class watcher and make an instance of the class watcher, and then I can just run it, and now it works for everything. So it works for all the standard library modules. It works on Runtime, Matplotlib, and so on. And just run it first, and then we can look at the implementation. So this is something that's not actually really metaclasses. So I say Python use class watcher, and when you do this, that takes a while because it's several hundred classes, and I print only the top 20 here, but you see I skipped 1700 lines that would be there. So I have this, I can have classes, 1760 classes, some of them are double somehow, they're not unique, and I can find out what classes I have. So it went through and just gives me a count of how many classes are defined in my source code. That's something you can do. It's a bit involved, but because the different, actually it's not a real meta class anymore. You just override this function that builds classes, and you can activate and deactivate it. That's a pretty interesting approach here, which I came up with. And you can do this. Good. So let's have a short look. It's a bit more complicated, but it has a lot of features because you can have a positive and a negative list and things like this. So you see, I have this one here, the class watcher, and you have only packages, ignore packages, positive list of packages names, only this package will be used, a negative list of packages. So you have filters, a positive and negative filter if you like, which are two frozen sets. You can specify them if you like. And then I go through. This is kind of a singleton, so if its instance exists, I erase it already. Exception, I cannot have multiple of them. And this is a counter, so I can count it here. And then I have this activate, and this activate has these packages, which packages I want, and I use super here. This is just a normal class with a new, and I have this build class, and this build class is the one which will replace the built-in class. We'll see this. And this takes a function, a name, the basis, the meta class type, and the keywords. That's new in Python 3. Here. And here I do the filtering. These are only packages. So the only packages. And if anything starts with it, then add the name. And this is ignore passages. Here I just ignore. This is just the filtering. And then I have this original build class function here. And then I just call this. This is the original one. And then return the class. And I have a static method which activates it. And activate just means take this original one and replace the original build class with my build class. Yeah, see, okay, this I'm saving the old one, built-ins build class, to the original one, and override the built-ins build class with my build class. And I set this only package, ignore packages. And deactivate would be setting it back. You might even think about using a context manager for this. That just comes to mind. There might be something, because it's something you do before and after. Yeah, and you could here with change something and then would put everything in context manager. But then you would need to change the syntax and indent everything. So it might be it's not a bad thing. And this is just a report. This is just printing out this table in the end. That's all. But the main thing is you have this build class, internal function, and you replace it with your own build class, which is this build class function I have in there. This with this one. Yeah. This is a static method, so it's just a function. That's something you can do. Okay, this is about some playing around, finding out what classes are defined, listing things, doing things. It works better in Python 3 and Python 2. And actually, we don't use the meta class anymore, but it took a meta class to get there to find this thing. Good. I have one more topic, and the last topic actually is the prepared method, which is new in Python 3. So that's a Python 3 only topic that doesn't work in Python 2 as far as I know. And this is prepare. And prepare is something that's even earlier than new. So when you work with new, you already get a dictionary of all these attributes. And when you get a dictionary, you don't have an order anymore. So you know, Python, in standard Python, dictionaries don't have any deterministic order. There's some kind of order, but you don't know what the order is, and you don't have influence in it. And in Python 3, there is a possibility to use a prepare method. There's a new __prepare__ method, and this is even earlier in the game than new, and then you know the order of, do you have a mean to get to the order of the attributes. So if you say, okay, attribute 1, 2, 3, 4, 5, then you can capture this, or you can capture this order. To do this, you have to kind of write a dictionary-like object. That's what I'm doing. I inherit from dictionary here, and I write a dictionary-like object that can be used instead of the original dictionary that holds all these attributes. And since you do this, you have to override the set item, and then you have the order of the thing. So you see, that's what I'm doing here. I have my new method class, which has this prepare method. I have a new method and I have init, but also have a prepare method. And here, I just return my order dict. So instead of getting a normal dict, I have an order dict, and I repair it with my keyword args here. And that's what I'm doing. And you have to prepare this order dict, and this is this one. This is replacing this dictionary. You see, I have an order. There's a list, which has an order, obviously. And then I have a few things, no special methods, no callables, whatever. I have to call the init because I override the init. And then the important thing, I have to set item. And so the set item will be called when you define a class with all the attributes. Then for every attribute, this set item will be called, and you know the order. It will be called for the first one first, the second one second, and so on. And that's where I get into order. And that's what I'm doing here. I get the name and the value, the key and the value. And you cannot, I can also, now is an interesting thing, typically in Python you can use the same attribute multiple times. And the last one override the first one. I can prevent this. If it was set already, I can raise an exception. That's what I'm doing here. Because if the key is found in self already, I raise an exception. So you can set it multiple times. And then also, if self no callables, then if it's callable, I say skip true, so I can skip it. And also no special methods. I can check for special methods. So everything that starts and ends with 2 underscores, the special method will be skipped. And only if it's not skipped, I append it to the order. So I can do some kind of filtering here. The thing is, I append it to this order, which is a list, and then I know, okay, this is the order. So I have an order. That's what I'm doing here. And then I get this, I return this dictionary. And this dictionary has this member order, which I put in. And I can set it now to the class member order. Yeah? Because I have the cdict.member order, which is cdict is this thing. Where's my member order? Here. This is my member order. This is a list. And this is the attribute, this is dictionary, because I replace the dictionary as a cdict, and now I can get it out and can put it in the class here. And I even have this attribute close true. And you will see later on when I override the set attribute, I can check for this closed, and if the closed is set, then I cannot allow setting anymore. So it's a very interesting thing. Now let's look at the application. We can come back. Now we have this attribute 1 and attribute 2. Now I can save this order and attribute 3. And just the question, if you want to count the method or not methods, you can set it if you like. Yeah. And if I do this, so it works. And now if I print out this member order, and now it knows the member order. The callables are in here, and attribute 1, 2, 3. This you would never have a chance to get out programmatically the member order, but with prepare you can. So see, if I comment this out, now I get an exception. So I set the same. Typically, you can do this, no problem. I set the same attribute twice, and I get an exception attribute defined more than once, because I do this if key in self here. That's where I go through and erase this attribute. That's something you can do. And also, you can also do this. You cannot set it later because it's closed. I can close it, and I can prevent setting attributes. Just prints it out, and then if I want to set it here, it says, okay, it cannot set attribute after class definition. So you can prevent people from setting things after class definition because I said here, so that's actually a second feature, I set this closed here. So after new is called, I said closed, and if closed is defined and is true, I use get attribute, and as a default I use false. So if it's not defined, it's false. But if it's defined and it's true, then I raise an attribute, so you cannot change it later. So quite a few things you can do. It's a bit work. It's several lines here, but once you've written it, using it later on is easy. You have access to this attribute order. So if you use SQL Alchemy and you want to have the order of the columns, that's the way to go. Yeah. Well, it would be. I don't know. It's Python 2. You must use a different way, but it's Python 3. You have this the way. So okay, you want to define, and you want to keep the order like some columns somewhere. Then this would be the way to go, because now you have the access to this thing, and you can have access to this definition here. Good. That's it as examples. So you can do quite a few things with the metaclasses. You have access to the very early phase when somebody defines a class. When a user defines a new class that has your metaclass, then you have a lot of leverage, a lot of power to do something with it, and you can change things. Do you have any questions about metaclasses? So I see metaclasses mainly as a tool to get information about your code base. So very often I have to dive into code bases I've never seen before, then you maybe just spend an hour, write a metaclass, and they give you some information what's going on. So how many classes are defined? Are they all the nice camel case or not, or something like this? You can do a lot of checks if you wanted to, without using an IDE. Everything that's really running at the time. If you don't have questions, you have to do exercise. Yeah.
In that new, you call type that used to get back a class, and then you set a bunch of stuff onto the class.
Yeah.
You also set it into the CDIC. As you insert member order and underscore close into CDIC to let the init do the work.
In the init, no, you can set an edict, but it doesn't have any effect. You can try. So in the init, you can set things, but it doesn't have any effect.
So even in the view, if you set the CDIC, the init doesn't get modified.
In here in the init, no, it's too late. If it's changed the CDIC here,
No, in the new, we changed the CDIC.
I don't know. I must have a reason that I've done this here. Probably it didn't work with setting. It's a good question. I haven't tried it yet. Probably should work. You should have access here to do something, and it should be the same. But if it's right in the CDIC or do close, it's supposed to be the same thing. But it should be possible to put it in the. But using an init typically, it doesn't have any effect. It's too late because it doesn't change things anymore. Because it doesn't move it through. You have it for reading, but when you modify it, it's a different copy or something. It doesn't work anymore. That's right. So if you want to modify, you have to do it in new. Otherwise, it doesn't have any effect. But those things typically, I need to try it out. There's so many different combinations you cannot reason about if it works. You just have to make some examples and see if it works or not. That's the easiest thing, because then you have the definite answer if it works or not. Okay, let's do some exercises. So on page 42 and 43, the last pages, I have 3 exercises. The first ones are pretty easy, just write. You can use some of these things as a blueprint, so you don't have to start from scratch, because you wouldn't make it in 10 minutes, write something from scratch like this. It's unlikely. Create a metaclass that prevents using names with more than 30 characters for methods of a class. So you can take one of the examples here that is doing some checking, and just check, because you have the name of the method, and you can check how long the name of the method is automatically. And this is something you can say, okay, a user, if you define a class with method names longer than 30 characters, I don't let you do this. And it's not like pylint that just gives you a message here, it wouldn't compile if you wanted to, just as an example. And the same thing, number 2 is very similar. Then you have doc strings with a minimum length of 5 characters. And filter out just special methods, everything that starts and ends with 2 underscores doesn't have the need, or doesn't have this requirement, doesn't need doc strings. And number 3 is just using this automata thing, playing loud a bit. Maybe you have some code base and you can check something. Might be possible. So we have, I'm not sure, is the official end 40 or 50? Anybody else? 40 is only in 10 minutes. So just, theoretically you can do this, just try, and then I'll show the solution. Yeah. So we only have 5 minutes and people started going. So maybe I'll show us the solution, maybe have a different solution. So that's one of the solutions you can have here for this exercise number 1. So I invented a new exception, you won't do this. And this is just pretty much, I copied most of the code from one of the examples. The only thing is now I need to check for the length of the name. So I have here the init is enough because you don't change anything, you just want to get information out of it. So the init is enough, the same thing, and you go through the attribute and the value, and you check if the value has the attribute call. It's the same thing as using callable. So if this is callable, it has to be a method. So there's no docstring for a list or anything for a class attribute. It has to be callable. And then you just check the length. Here, there's the length. And if the length is more than 30, then you start raising an exception. And I made a little bit a longer exception name here. And that's it. I raise the exception. So I have put the information in this text, what's going on, what the name is in the length. And then I just use super here. And then I have a class. This is Python 2 syntax here. So if you're in Python 3, which I'm here, I have to do something like this and comment this out. Yeah. Now, and then if I do this, this method is fine. This method has a very long name, and you get a coding exception, name exception, which I raise here, and it tells me, okay, name exception, the name method is too long. Only 30 characters are allowed, but it is 48 characters long. So the same principle, so you can apply this to a lot of different things. You just go through and you have this information. In this case, you have the length of the methods. And you don't like this too long, that's why you reverse this exception. You say, doesn't work. Yeah? And the thing is, the user cannot define classes that have longer names. It doesn't work, it just doesn't compile. I don't know if you want this, but you can do this. Okay, the same thing with the docstring. This is exactly the same principle. Exercise 2. And you see, if you look at this, very simple. I just have my exceptions and make it. There is special method. I have a special function that just checks the special method. Just use a regular expression for a special method. Gave you this one. Just we found a special method if it's a special method, and this is the same thing. It has to be callable. And then I go in here and I get a docstring, and let's just check the length of the docstring. So if the docstring length is less than 5, I raise an exception. Same thing. Nothing special. Not very difficult. It's a bit code to write, but nothing difficult. And if there's no docstring at all, I raise a no docstring exception. So there's 2 different exceptions. No docstring and docstring too long. Of course, I cannot tell if the docstring has anything useful. That's beyond the scope of this tutorial. Then you have to do one of those machine learning AI things. But yeah, so this is something you can do. And again, I have to change the syntax to Python 3 syntax here because I'm in Python 3. Here, Python 3, and then you can do this, and you get an exception down there that the docstring is too short. Found 3 characters, minimum length of 5. Yeah, that's something you can do. So, just as a sample, you can do many more things. You can count how many methods start with an underscore, how many methods start with a test, and whatever you want. There's a lot of statistics you can do, and it's not that difficult. It doesn't matter if it's 10 classes or 500. You can go through all of them at once, typically, once we get it in the meta class somewhere. Good. The last tutorial for the last tutorial session is just 2 more minutes, and we are right on time and finished. I hope you got something out of it. I have one last slide, actually. One last slide. So thank you very much. So if you want to reach me, my contacts is there. It should be also in the email you got from me. If you got one, if you took my card, send me email, you get my photo which in there. So if you have interest in Python training, we do Python training. So just contact us. We have a lot of different topics. We do a lot of in-house training. So if you need anything, just let me know. And then so please give feedback. So I gave this link. So go in there to SurveyMonkey, and it should just take a few minutes. It's like 5-10 questions, something like this, just yes, no, or something like multiple choice, not so much. So just give feedback. Thank you very much. I hope you got something out of it, and I wish you a very nice PyCon conference. So if you didn't get my email, just here's the card. You can send me email. I will send you email back.